Hello, everybody. Thanks for coming to this talk right after lunch. Hope everybody's nice and full. So welcome to my talk, Hiding in the Clouds. I'm using Azure DevOps Services to bypass Microsoft Sentinel Analytic rules. I'm Brett Hawkins, and I'm with IBM X-Force Red. Before I get started, I just want to note I have a link to a white paper I posted this week on this research that's got full details on my research I'm about to cover. So who am I? I'm Brett. I'm the capability lead on the adversary services team at IBM X-Force Red. Prior to that, I was in a number of different roles, both on offense and defense at some different companies. I've written a number of open source tools, including ADOKit, which I just released this week, and you'll see a demo of in this talk. I've also spoken at a number of conferences. If you're interested in any of my public security research, whether it's white papers, presentations, blog posts, tools, I have it at the link on the left there. So how did this research come about, and what were drivers on this research? First off, threat actors, they're continuing to target DevOps systems and personnel. And they're doing this to conduct software supply chain attacks, source code theft, and to facilitate data exfiltration. 2020 was the big one, the SolarWinds software supply chain attack. Last year, the Lapsus group compromised Microsoft's internal Azure DevOps system to conduct source code theft. And then late last year, early this year, you had DevOps engineers that were targeted and compromised at both CircleCI and LastPass to facilitate data exfiltration. And then just last month, Microsoft announced that a North Korean threat actor group conducted a software supply chain attack with CyberLink Corp. Additionally, more organizations are continuing to adopt cloud-based services, and that's caused attackers to target these cloud-based services as well. The big one this year was the Stormo 558 threat actor group, who compromised Microsoft cloud-based services. And in our adversary simulation engagements, we're seeing more and more clients that are migrating from on-premise DevOps systems to cloud-based. Specifically, our team sees a lot of Azure DevOps Services. And prior to this talk, there was a lack of comprehensive research and tooling on attacking the cloud-based platform. And the last driver there, I wanted to see the effectiveness of the default Sentinel detection rules for Azure DevOps. I had three main goals with this research. First, I want to highlight the importance of testing default detection rules. Second, I want to inspire future DevOps research. Last, I want to bring more attention to defending cloud-based DevOps platforms. Now, this holiday season, I have three takeaways or gifts for you all. So the first one, you're going to learn how to bypass the default Sentinel rules for Azure DevOps. You're going to learn how to improve the default Sentinel rules for Azure DevOps. And then lastly, you're going to gain awareness of both privileged and unprivileged attacks against Azure DevOps services. What's new in this research? So there's multiple new things. First off, using public detection rules as a guide on defense evasion. There hasn't been a lot of talk publicly around building into your offensive methodology whenever you're attacking a system to first look at any publicly posted detection rules to see if there are any trivial bypasses you could use when you're attacking that system. Second, there haven't been any public talks that show the effectiveness of the default Sentinel rules for Azure DevOps. Additionally, you're going to see a comprehensive approach in this research attacking Azure DevOps services along with the new tool ADOKit that I released this week. You're going to see new methods to retrieve pipeline secrets that bypass Azure DevOps security controls. You're also going to see a new undocumented REST API method to perform code reconnaissance that I discovered. And last, you're going to see a new way of interacting with the Azure DevOps Services REST API by the abuse of an authentication cookie. Now, my perspective on this, I'm currently a red teamer. Previously, I was a SOC analyst. I'm not any of those roles listed on the right, and I definitely don't pretend to be. Although there's been a lack of comprehensive research on attacking Azure DevOps Services, there's been a lot of really great work on individual attack scenarios against the platform, and I want to make sure I call out these people and their Twitter handles where applicable. Links to their actual work is included in the appendix slides of this presentation, as well in the white paper. So now we're going to go ahead and get started on a background of Azure DevOps Services. So a little history. In 2005, Microsoft released Team Foundation Server, or TFS, and that included TFS Server and Visual Studio Team Services. Then in 2019, they rebranded to Azure DevOps, or ADO, and that included two offerings. You have Azure DevOps Server and Azure DevOps Services. The difference between these two offerings, so Azure DevOps Server is going to be the on-premise offering, whereas Azure DevOps Services is their cloud-based offering. I specifically focused on Azure DevOps Services for this research. Now, some common terminology you might hear me mention throughout this talk. So an Azure tenant can have one-to-many collections or organizations, and then within a collection, you can have one-to-many projects. And there's a number of different components that are included within a project. The two you're going to primarily hear me mention are Azure Pipelines and Azure Repos. Azure Repos is the source code management piece, where your source code actually lives, whereas Azure Pipelines is the CI/CD component. You also may hear me refer to a team. Team is just a set of basic project-defined members. Now, to access Azure DevOps Services, you have two options. The first one is a web interface, and you're going to access that at dev.azure.com/yourorganization. Also, REST API has a REST API available, and you're going to see the abuse of that REST API in my research. You can access the REST API either via OAuth 2.0, personal access tokens, or as you're going to see with an authentication cookie. There's tons of different scopes that can be applied to the REST API, a bunch of different components. I'm not going to go into each of these scopes, but I do have a reference link in the white paper where Microsoft describes all of these. So in terms of security groups, they're either at the project or at the collection level. And these security groups are going to basically give you different permissions to interact with different components within Azure DevOps Services. So at the project level, the two privileged groups are going to be project administrators and build administrators. At the collection level, project collection administrators is the administrative group. However, project collection service accounts by default is a member of project collection administrators, so that is also a privileged collection group. The other two groups listed there are listed as privileged because they are able to interact with and retrieve build pipeline variables and secrets. In terms of logging, so in Azure DevOps Services, if there is an auditable event, so for example, adding a user to a group, that is going to be logged within the audit log in the Azure DevOps auditing schema. From there, you can send those logs via an audit log stream to a SIEM such as Microsoft Sentinel. And one thing you're going to see in this research is that I did identify some rooms for improvement in terms of what is logged within the platform as it relates to the entire attacker lifecycle. Now, if you are sending your logs to a SIEM such as Microsoft Sentinel, there are several open source default rule sets for many different Microsoft services within Sentinel. Specifically for Azure DevOps, there are 18 default rules that I focused on for this research to see how they performed in terms of attacks on the full attacker lifecycle. Now, these are open source rule sets. You can access them at the URL on the bottom right, Azure/Sentinel. So these are available for you to analyze. Again, these are the default rule sets. And what you're going to see is that in this research, I did identify some room for improvement in terms of the breadth of coverage for these rules as it relates to the full attacker lifecycle, as well as some trivial bypasses that are available. So now that we've kind of got a background on Azure DevOps Services, let's get into actually attacking the platform. So with initial access, 3 different options. You're going to need some sort of credential to get initial access. Now that could be username and password, personal access token, or an authentication cookie. Now, common methods of obtaining these type of credentials could include file shares, intranet sites, user workstations, conducting social engineering, or any unprotected or misconfigured internal network resource. And we commonly use those methods in our adversary simulation engagements to get these type of credentials. Username and password, again, very straightforward. You log into the platform, to Azure DevOps Services. If MFA is configured in the Azure tenant, then you would be subject to MFA. With personal access token, what you need to do, the screenshot on the top, you need to base64 encode that personal access token so that you can use it against the REST API. And to test if that personal access token is valid, you perform the below curl request, and if you get an HTTP status code 200 back, it's going to be a valid PAT. Now this is the new one here. Whenever you successfully authenticate to Azure DevOps Services, you are given a user authentication cookie, and it's scoped to .dev.azure.com. Now by default, this cookie is going to be valid for 7 days. And you can use this cookie to interact with the Azure DevOps Services REST API. Once an attacker has initial access into Azure DevOps Services, they're going to start performing reconnaissance. I've got these different types of reconnaissance here. These are going to be the most valuable to an attacker, and you can conduct all of these with the exception of repositories recon via the web interface or the REST API. Now I have full details in the white paper how to do each of these via both methods, but you're going to see a little bit with the REST API later. In terms of detections for the different types of reconnaissance I just listed, there are no detections with the default Sentinel rules for Azure DevOps, and that is because I mentioned in order to build a detection, there needs to be an auditable event, and reconnaissance activities are not auditable events. Therefore, they're not going to be included in that Azure DevOps auditing schema. Another thing that the attacker is going to do early on in the attacker lifecycle is persistence. You want to maintain persistent access to Azure DevOps Services. Two main options here, and that's going to include the creation of personal access tokens or SSH keys. You don't need any special type of permissions to create these. You can create them either via the web interface or the REST API. I'm going to show a little bit later how to conduct these with the REST API as well. Now, creating an SSH key or a personal access token, that is an auditable event. However, there aren't any type of detections in the default Sentinel rules for Azure DevOps that cover this activity. Therefore, I included a new detection rule as part of this research I'm going to show a little bit later. After an attacker has obtained initial access, they've done reconnaissance, and they've added persistence, they're going to start performing privilege escalation. Now I'm going to show a number of different privilege escalation attacks here, and the security group permissions required vary between them, so I would just ask to just review the white paper. I have full details on what permissions are required for each of the attacks. So if you have appropriate permissions, you can add a user to a privileged group, and that's either going to be at the project or the collection level. You can conduct this via the web interface, the REST API, and I've also got this functionality built into ADOKit. In terms of what is detected with the default Sentinel rules for Azure DevOps, there's currently some issues you can see here. So for example, if you add a user to build administrators or project collection build administrators, that's not covered. And I'm going to explain a little bit later why that's the case with the current rule logic that's in there. So another useful thing to an attacker is modifying an Azure pipeline, a build pipeline. So if a project is using an Azure pipeline, again, Azure pipeline is going to be the CI/CD component of a project. If it is using an Azure pipeline, there's going to be an azure-pipelines.yml file in the root of the repository. Now these YML files, they're configuration files that have different instructions within them. And within Azure DevOps Services, you're going to have a pipeline agent that runs the instructions in that configuration file. Now, this agent can either be a Microsoft-hosted agent, meaning you do not have control of that infrastructure of that agent, or you can have a self-hosted agent. In that case, you control the agent and the infrastructure. You can run that on your own infrastructure. Now, once you modify this configuration file, that's going to cause the pipeline to run for that project. And in terms of the manipulation of this configuration file itself, there's no default detections within Azure DevOps, Sentinel for Azure DevOps that cover this. And one thing else I do want to mention is there's tons of built-in tasks within these configuration files that are useful from an attacker standpoint. So for example, one of the built-in tasks available is like an Azure Key Vault task that you can use to interact with Azure Key Vault secrets and such. Kind of building off that, if an attacker has gained access to Azure DevOps Services and it has appropriate permissions to modify this Azure pipeline configuration file, and the pipeline is using a self-hosted agent, an attacker can use that to pivot to, for example, an organization's on-premise infrastructure. Now, this can be especially useful if an organization is using a self-hosted agent running on their infrastructure and it's connected to, for example, their on-premise Active Directory domain. So that would allow an attacker to pivot from Azure DevOps Services to an organization's on-premise infrastructure. Another attack here, retrieving build variables and pipeline secrets. So within these Azure pipeline configuration files, you can think of them like using them kind of like a programming language. You can use variables within them, whether it's to store, to conduct some sort of math operation, or to retrieve credentials that need to be used to authenticate with Azure Resource Manager or some other resource. And you have a couple different options here. So you have build variable values, and these are going to be clear text. So on the screenshot on the right, an example of this would be some variable 1 and some variable 2. These would be examples of build variable values. And these you can copy and paste the data out. If you're using a pipeline secret value, that's going to be hidden. So you can see in this case, secret URL is an example of a pipeline secret value. If I try to copy it out, it doesn't give me the value. If I try to print it in the build output, it's going to be hidden as well. Some examples of other pipeline secrets that we come across that organizations use are going to be Azure Key Vault secrets and service connection credentials. And again, because these are secrets, you cannot display these in their original form. However, you can bypass the security control. And to do that, what you would do is you would display the secret in some other form. So for example, splitting the secret in half, in reverse, or any other string manipulation technique. So what you can see in the screenshot there is that previously that secret URL that I couldn't print in the job output, I printed it out in its first half and second half to actually get the value out. So this just kind of shows how you can get around that security control for trying to protect secrets. Now we're going to get into some defense evasion techniques. So I talked about pipeline agents a little bit, how you can have a self-hosted or a Microsoft-hosted agent. So these agents will belong to an agent pool. An agent pool can have one-to-many pipeline agents. Now, one thing an attacker may try to do is create their own agent pool. That way, they're not using an agent pool owned by the organization, and it gives them a little more flexibility that they can spin up and spin down agent pools. Now, this type of attack is going to be detected. So if an attacker creates an agent pool and then deletes it to cover their tracks, it's going to be detected by the default Sentinel rule that I have listed there. Another thing an attacker could do if they have appropriate permissions, I mentioned previously that if you want to send your Azure DevOps Services logs to a SIEM like Microsoft Sentinel, you would do so with an audit log stream. Now, if an attacker wants to disable this audit log stream so that your SIEM is not getting those logs, they can do so with the appropriate permissions. However, this is going to get detected. Microsoft has a default Sentinel rule for Azure DevOps that's going to detect this activity. So whenever actions are conducted within the Azure pipeline, those artifacts, there's a retention policy you can set for the number of days to keep those artifacts. Now, the lowest value you can set this to is 1. So if an attacker wants to reduce evidence of their pipeline activity, they can reduce this value. And there is coverage in the default Sentinel rules for Azure DevOps with that rule listed there that will detect this activity. Another thing an attacker might want to do is inject some sort of malicious package into the pipeline. And they can do that by adding an external package source, as you can see in the top right screenshot. This activity is also going to be detected with the default Sentinel rule for Azure DevOps that I have listed there. Now, there's a REST API available in Azure DevOps Services, and there's tons of different things you can do in the REST API. One of them being reconnaissance. So again, these are the 6 most useful types of reconnaissance from an attacker perspective. I've got the REST API documentation listed there. The white paper also has full example commands on how you would use each of these REST APIs. But I specifically want to call out code reconnaissance. So I discovered an undocumented method within the search REST API that allows you to do code reconnaissance, specifically the code advanced query results method. Now, this is useful from an attacker standpoint because one thing that's very valuable to an attacker, once they have access to something like Azure DevOps Services, is they're going to want to try to discover code secrets doing code reconnaissance. So this undocumented method can be used, and this is actually built into ADOKit as well. And again, just to kind of say it again, there's no detections with the default Sentinel rules for Azure DevOps for doing recon with the REST API because reconnaissance activities are not auditable events. Persistence. So you can create personal access tokens and SSH keys using the contribution model and a stolen cookie. You need to use a cookie because a PAT cannot be used to create other PATs or SSH keys. And there's no detections for the creation of these used for persistence, but I have a rule a bit later I'm going to show that will actually detect this activity. You can add a user to a group with the memberships REST API, as I showed right there. Now this activity with the REST API, adding a user to a group, that does get detected by the default Sentinel rule listed there. However, I'm going to show how to bypass this rule a little bit later. You can also retrieve pipeline variables via the build definitions REST API. So I mentioned previously there's build pipeline variables and secret variables. So the actual build pipeline variables, you're going to be able to get the variable names and the actual values. And then for the secrets, you're just going to be able to get the secret name, not the actual value. You can get service connection information with the service endpoints REST API, and this is just going to be high-level information that you can use for further targeting for projects that are using service connections. So basically, it's going to give you like the GUID, the name of the service connection, the project it's associated with. So if you have appropriate permissions, you can use like one of the techniques I showed for manipulating that secret to display the credential information. So I gave you a background on Azure DevOps Services, and I also showed how to perform a number of attacks against it and how the default Sentinel rules for Azure DevOps stacked up against it. So now I'm going to show how to bypass and improve several of these rules. After that, I'm going to show ADOKit along with a demo, and then I'll wrap things up with defensive considerations. So specifically, I'm going to show how to bypass these 5 default rules here. This first one is very straightforward. So what this rule is looking for is if you authenticate with a PAT and your user agent string is any in the list right there. So very simple bypass, authenticate with a PAT, and use some random user agent string that's not in that list. Pretty trivial. This one here, this is looking for if you authenticate with a PAT and you add a user to a group, execute a service connection, modify a build or release pipeline, or if you perform any operations related to projects, the audit log, extensions, etc. So to bypass this, you can do any of those actions you want with the REST API, but instead of authenticating with a PAT, authenticate with the user authentication cookie. This rule here is specifically monitoring for any users who have modified a release pipeline that don't typically create or modify release pipelines. Now the issue with this rule is it's only looking at release pipelines. It's not actually monitoring build pipelines. And something in my research you've seen is that I'm specifically targeting the build pipelines, not the release pipelines. And because of this, that activity is going to go undetected. This rule here is pretty straightforward, but there's an issue. So this is looking for any user that is added to any of those groups listed there. Now, the issue with this is that build administrator should have an S on the end, and project collection build administrators is not included either. So for this rule here, you can add a user to project collection build administrators or build administrators, and it's not going to get detected by this rule. Now this rule here, it's specifically monitoring for if a user is added to project collection administrators or if you add a user to project administrators for a project. but in its default state, it's not going to actually alert on adding a user to the project administrators group because you need to actually set the monitor all projects to true, or you need to add specific projects you want to monitor in projects to monitor. Now I showed how to bypass 5 of these different rules, so now I'm going to show how to improve a few of these and then a new rule that I created. And with all of these, obviously you want to perform tuning in your environment, to reduce false positives and such, but this is kind of my take on the improvements for these. So this first one here, I would rename it to be more of a generic kind of Azure DevOps REST API misuse. And then I would add, you can see the blue text there is what I would add. So in addition to looking for the authentication of a PAT, also look for the authentication mechanism of the user auth token, because as you saw in this, you can use that to interact with the REST API. For this rule here, update it to detect the build administrators or project collection build administrators. For this one, really straightforward, set the monitor all projects to true. That way you can detect a user being added to project administrators for any project. And this is a new rule here that I created. So specifically, this will detect the creation of a personal access token or an SSH key, either via the web interface or the REST API. And here you can just see an example of this alert firing in my lab when I was creating a personal access token to be used for persistence. So you saw throughout this presentation a number of different attacks that utilize the REST API. So what I wanted to do is create a tool that both offensive and defensive security practitioners could use to simulate attacks against their Azure DevOps Services instance. That way they can test detections. And that's how ADOKit came about. So ADOKit, I just released it this week. So it is a C# command line tool. So you can use it, for example, on a file system or in memory on a command and control framework. It allows you to conduct actions programmatically using the REST API in Azure DevOps Services. I've got 35 different modules that include reconnaissance, privilege escalation, and persistence. It supports authentication either with a personal access token or a cookie, and it's open source, available to the community. So I have the URL listed on the top left. The repository has full documentation as well in terms of what's available and how to use the tool and everything. If you come across any issues, feel free to open an issue on the repo and I can take a look at it. So now we're going to go over a demo. So just to set the stage, we have a Cobalt Strike beacon on a user system here. Cobalt Strike is a common command and control framework used by both offensive security practitioners and by threat actors. On this system, we've used something like Sharp Chrome to dump the user's cookies. And in the cookie dump includes this user authentication cookie. So what we're going to do is we're going to authenticate with this cookie and use the check module within ADOKit. Now what's this going to do? It's going to tell you whether this credential is valid. So we're going to go ahead and run this here. Now all modules in ADOKit support, like I mentioned, either authenticating with a PAT or a cookie. And you can see here this cookie that we stole, it is valid. So the organization exists and the credentials are valid. So at this point, we have initial access into Azure DevOps Services. The next thing we want to do is situational awareness. We want to see what type of privileges we have as this compromised user. So for that, we're going to run the Who Am I module. Now this is going to tell us what the username is that we are acting as, the display name, user principal name, and then it's going to tell us our security group permissions. So what at the project level and at the collection level. So you can see here, I'm just going to highlight, we are user 1 in this Hogwarts School US Azure tenant. And then you see the group memberships. So number of different group memberships. Most juicy one here is going to be project collection administrators. So at this point, we've got initial access with a stolen cookie to Azure DevOps Services. We've done our situational awareness to know what permissions we have. The next thing that we're going to do after this is we're going to add persistence. As I mentioned, that user authentication cookie, it's valid by default for 7 days. So once that cookie expires, we want to make sure that we maintain access. So for this, we're going to use the create pat module in ADOKit to create a personal access token. So what you're going to see in the output here, it's going to create a personal access token for us. It's going to give us back the ID, the name. So all personal access tokens created with ADOKit, the name is going to be ADOKit-8 random characters. It's going to give you as much permissions, privileges as it possibly can with your current user. And then also the maximum expiration date for a personal access token in Azure DevOps Services is 1 year. So it's going to make that valid for a year from when you created it. Now the most important thing though is the token value. Make sure you copy that out. So that's what you're going to actually use to authenticate against the REST API. That's your actual personal access token that you created. So we're going to go ahead and copy this value out. And we're going to use this in some subsequent requests. First thing we're going to do is we're going to run the search code module. Now, with the search code module, it's using that undocumented REST API that I previously mentioned for doing code reconnaissance. And we're going to search for password. The search is case insensitive, so we're going to search for any code that has password in it. Now what this is going to list out, it's going to list out any files and then the matching lines that have password in it or whatever you're searching for. So you're going to see the output here in a second. So you can see here we've got some different matches. We got 4 different files along with 5 total matches because one of those had 2 matches in it. The next couple modules we're going to run after this are more privilege escalation modules. So specifically extracting build pipeline variables and build pipeline secrets. So first thing we're going to do is we're going to run this get pipeline vars module. You can run this against specific project or all projects. Now what this is going to do is extract any of those clear text build variables and build variable names and values from pipelines for a given project or all projects. So for example, if a developer is using a build pipeline variable that has some sort of credentials in it and they didn't mark it as a secret, you can uncover this information. You can see there, it's going to list the project, the pipeline variable name, and the pipeline variable value. The last module I'm going to show here is the get pipeline secrets module. Now for this, similar as get pipeline vars, you can run this against a single project or all projects. So this is going to give you the name of the secret, and then obviously the value is going to be hidden. But this module can help you for further targeting because if you identify projects that are using secrets, you can use like one of the methods that I previously showed to modify the Azure pipeline configuration file to extract that secret value out. So that's just a few of the different useful modules within ADOKit. Like I said, there's 35 different ones all in the repo. It's got tons of different functionality available. But now we're going to go over some defensive considerations. With ADOKit, so for use in its default state, I've got a YAR rule based on the C# project GUID. I've also got a snort rule because I use a hard-coded user agent string for the different requests. I've also got some Sentinel rules on the repository that will detect when any auditable event is conducted with ADOKit. And I've also got some persistence IOCs added because any pat or SSH key that is created, the name is prepended with ADOKit dash. 3 main kind of recommendations for the Azure DevOps Services platform itself. Microsoft has a really great best practices guide, and I have this linked in the white paper that's got tons of different recommendations for hardening your platform. Second is to integrate a proactive secret scanning solution. Something like Azure DevOps that can proactively detect the use of credentials when they're being insecurely stored or used within code, and also to scan for known code vulnerabilities. Then my third recommendation here would be to implement the Sentinel rule improvements for Azure DevOps that I showed today. So now we're going to wrap things up. I made some high-level observations in terms of opportunities for improvement, both for the default Sentinel rules for Azure DevOps, as well as logging within the Azure DevOps Services platform. So first off, on the detection rule front, as you saw, there's a number of different trivial bypasses that are available within those default rules. But a lot of that just comes down to these rules need more tuning and contribution from the community. Additionally, the breadth of coverage for the available default rules, it's not going to cover everything in the attacker lifecycle. For example, there aren't any default rules that would cover reconnaissance or persistence. But some of that comes down to logging. So I mentioned multiple times that reconnaissance activities, they are not auditable events within Azure DevOps Services. Or another logging observation that I found is that with the build pipeline auditable events, the coverage is not going to cover everything. So an auditable event would be if you add like a variable to a build pipeline, but it's not going to cover, there's not going to be an auditable event if you were to, for example, modify the configuration file and do some of the nefarious things that I showed today. I want to leave you with these three things. First off, don't trust the default rules. Always test default detection rules and continuously perform tuning. And that's never going to be a finished thing. Obviously, you're going to be continuously tuning rules, and you just need to make sure that you are continuously doing that. Second off, attackers are not going to stray away from attacking DevOps platforms. These systems, they're integrated with a lot of other important systems in the enterprise. A compromise of one DevOps system and organization could lead to the compromise of another organization. These DevOps systems are very powerful, and so we need to make sure that we are securing these systems, giving them the attention that we would other technologies like Active Directory, and making sure that we educate and secure the personnel that are interacting with these DevOps systems on a day-to-day basis. The third one here, the world is continuing to adopt and migrate to cloud-based technologies. Because of that, attackers then are going to target these systems. So we need to make sure that the logging conducted in these cloud-based services is sufficient and that we are continuously developing detection rules for the abuse of these systems. I want to thank the below people at IBM X-Force, because without them, this research wouldn't have been possible. I highly recommend following them on Twitter. They're really great. I want to give a big thank you to Chris, John, Matthew, Patrick, and Sanjeev. If you have any questions, it looks like we just have a couple minutes, so it might be better if you come up afterwards. You can ask me any questions you want or out in the hallway. But I've got my Twitter listed there as well. Feel free to connect with me if you have any questions. And I've also got the white paper listed there as well, in terms of it's got the full details on the research I just went over today. So with that, I just want to give a big thank you to Black Hat for allowing me to come speak, and I also want to thank all of you for attending my talk as well. Thank you.